This problem is not too far away from the one that we just did. It's just that's a different kind of radical on here. But I still need to have that radical be isolated. So I'm going to add this chunk of stuff to both sides so I can get a radical isolated. That's going to leave me with the cube root of 6x minus 11 equal to the cube root of 4x minus 1. And now that the radical is isolated, the proper way to get rid of that root is to cube both sides, because cubing and cube rooting are opposites, leaving us with 6x minus 11 equals 4x minus 1. Now this should look relatively familiar, and if it were me, I would try to get the x's on one side first and keep them positive. So I would actually subtract this from both sides first. That would give us 2x minus 11 equals negative 1. Then solving this for x, we have 2x equal to 10, which means x equals 5. And I do, again, need to take the time to plug this back into here. Now I will say, if you have an odd number on your root, it's okay to odd root a negative number. Like the cube root of negative 8, that exists. It's negative 2. The cube root of negative 125 is negative 5. So if the root is odd, you can have positive or negative numbers underneath here without having to dip into complex numbers. So we'll take this 5 and we'll just see what's happening. If I take that 5, I get the cube root, do this in red, this is a mental check. The cube root of what? 30 minus 11, which is the cube root of something gross. My goodness, 19? I don't know what that is. And then we have minus the cube root of 4 times 5, which is 20, minus 1, minus, again, the cube root of 19. So even though I don't know what this actual value is, I do know it's the same thing twice. I'm subtracting it from itself, so it will be 0. So I'm definitely sure that this answer is correct, and I'm pretty happy with that. So it's all good.